headquarters of General Motors Holdings at Fisherman's Bend, Melbourne, is located the division responsible for research, design and engineering. Here, more than 300 men and women, many of them highly skilled specialists, begin the planning of each new car project. On the results of their efforts largely depends the success of the vehicle to be manufactured. When the type of car to be built has been decided by market and engineering research, its final form is evolved by the design staff. Creative engineering artists develop their individual ideas for all features. Their conceptions, futuristic, glamorous, utilitarian, are considered or rejected until finally there emerges in line, form and colour a clear picture of the car to be. From this is developed a full-scale drawing, almost three-dimensional under the skilled hands of the expert stylist. The design is advanced to a 3/8 scale model in clay, true in external detail and a complete miniature of the future car. Now begins the creation of a full-scale wood model with clay surface. Demonstrating the practical growth of the project, this model reproduces all the intended external features of the prototype. The ingenuity of the artist goes into the creation of a most realistic model, and the wood clay mock-up has the appearance of a real car. In this form, it's displayed for discussion and criticism by company executives. As the project involves an expenditure of millions of pounds, this is a critical stage. For final decision must be made on the suitability of the design from the viewpoints of market requirements and volume manufacture. A final decision is made only after those responsible for product design, engineering and manufacturing have reached agreement. Following their approval of the overall design, stylists advance the development of components, such as instrument panel, radiator grille, emblems, and other features. Styling engineers seek the ideal combination of beauty and utility in every component. They impart to their drawings a remarkable impression of depth and perspective. Exterior and interior colour schemes are chosen with equal care. A colour expert advises on shades of bodywork and upholstery, in combinations having the greatest appeal to prospective buyers. Bulk orders for paint and trimming materials in these colours must be placed long before the stage of volume production is reached. When every feature of design has been approved, including each mechanical and body part, detailed working drawings of each are prepared by skilled draftsmen trained in this exacting work. The intricate nature of their work is illustrated in this full-scale body drawing. Every one of the thousands of components of the car must be drawn and given its final specifications for dimension, strength, and structure. cylinder block or engine manifold, transmission or connecting rod, accurate scale drawings must be prepared. Multiple copies of each final drawing are speedily produced on this machine. From these blueprints, tools will be made for manufacture, and huge quantities of parts and raw materials will be ordered. Master copies of all drawings are filed in fireproof vaults. Now work begins on manufacture of the prototypes, which must undergo practical testing before volume production can begin. Skilled tradesmen in the experimental engineering section use special equipment to construct the many parts for these prototypes, which virtually are hand-built cars. It is here that the highly skilled artisan, as distinct from the process worker later employed in volume manufacture, maintains the extreme precision required in boring, milling, grinding or turning such parts as differential carriers, camshafts and axle housings. As each part comes from the experimental machine shop, it's checked to the drawing specifications with precision instruments. Infinite pains are taken to maintain the greatest accuracy. Now, after months of work by engineers, stylists, draftsmen and tradesmen, the first prototype engine takes shape. From the bare cylinder block, skilled hands build up the visible result of the designer's work. A test bench run breathes first life into the advancing project. Side by side with the creation of the first engine, work goes on in the experimental body shop. Wooden patterns impart their shape to metal body panels in a hydraulic stretcher press. Under tremendous pressure, the steel sheet slowly assumes the contours of the wooden die. Panel beaters put the finishing touches to body sheet metal. The stylist's lines now take shape, and the body shell progresses towards its final form. Welders play an important part as sub-assembly begins of smaller components. On the surface balance alignment jig, the rigid checking of dimensions continues as body parts begin to fuse into the body shell. The first experimental car has been completed. Now it's subjected to further careful checking on a precision-built flat surface. Then it's ready for more rugged practical tests in the experimental workshop and later on the road, which will prove the vehicle under all conditions. To test the effectiveness of body sealing, the car is sprayed from every angle with water under pressure. Wheels are aligned and checked on a precision balancing machine. Steering wheel effort is measured. And with the aid of finely graduated gauges, petrol consumption and engine efficiency are determined. The efficiency of front-end springing is measured in a drop test. and the reaction of brake pedal pressure is hydraulically recorded. On the completion of these exacting engine and body tests, the car is driven from the experimental workshop to take the road for the first time. A fifth wheel is attached to ensure accuracy of the instrument readings. Other tests already made in the workshops are duplicated under road conditions. The prototype cars must cover thousands of miles of continuous testing over all types of road before final approval is given for volume manufacture of any component. To the experimental engineering section, the car goes for further grueling tests. Here, on the chassis dynamometer, it's possible to reproduce conditions met on the worst outback roads. Particular attention is paid to shock absorbers, springing, and ruggedness of front and rear suspensions, and their ability to withstand rough treatment. Every reaction of the car is carefully noted. The effects of some of these tests could be achieved only after many months of driving on rough roads. While these road and dynamometer tests continue, they are paralleled in the laboratory by scientific analysis of all metallic parts. A spectrograph analysis is made of such components as gear and crankshaft forgings to ensure that specifications agree with the rigid standards demanded by the company. Chemical tests of lubricating oils and electrolytic analysis of metallic components are also made to ensure the same high quality is maintained. In the special electrical laboratory, a cathode ray oscilloscope measures high-tension voltage of ignition coils. A check is made on distributors. The many other intensive tests are dramatically illustrated in the experimental test section. Here, components are subjected to forced wear, comparable with years of normal life. Starter buttons are operated automatically and continuously, and the steering wheel is rubbed to simulate hard wear. Oil pressure switches operate for days on end. High-tension coils and distributor systems are given weeks of speeded-up tests, the equivalent of years of normal operation. Carburetors are flow-tested to ensure maximum engine power and economy. General Motors Holden's engineers, with this wide range of ingenious equipment, can find the answer to most engineering problems. Door locks are tested, if necessary, to destruction. Wheels are strained with heavy loads to duplicate the effects of cornering at high speeds. All other vital parts are tested continuously to determine their strengths or their weaknesses. Cushioned springs take the weight of above-average adults in a bumping test. Gears are automatically changed many thousands of times. A weaving machine puts great strain on the frontal section of the body and instrument panel. Under these continual stresses, any weaknesses would soon be revealed. completed prototype engines go to the engine dynamometer cells for exhaustive tests at all speeds and under varied loads. Here, any section of the engine and transmission can be isolated for special attention, and every phase of its performance accurately gauged. After these exhaustive bench, workshop and laboratory tests, the prototypes take to the road again for further rugged trials. Day and night, week in and week out, through summer and winter, and over every type of road surface that would normally be met in the life of a car, the test models are hard driven by expert driver mechanics. The widest variety of road surfaces and grades are chosen deliberately. Dusty tracks check engine and body sealing. Steep hill climbs, sharp S-bends, and long stretches of open road provide speed and acceleration tests. Only when the car emerges from all these exacting tests with satisfactory results can the final stamp of approval be given. Then production begins. In General Motors Holden's plants in the 5 mainland states, more than 10,000 people, using millions of pounds worth of special machines and equipment, swing into volume manufacture of the approved car. In the fully mechanized foundry at Fisherman's Bend, Melbourne, all the grey iron castings are poured. Castings from the foundry move on to the Fisherman's Bend machine shops for final processing. Cylinder blocks, cylinder heads, and other cast parts move steadily along the production lines. On other lines move the forgings and machine parts that will become precision crankshafts, gears, and all other working parts of the Australian car. Completed axle assemblies are sprayed as they move along conveyors toward final assembly. Each day, large numbers of engines are built, assembled, and tested. Engines which will be sent to the vehicle assembly lines in the GMH plants in each of the mainland states. At Woodville, South Australia, 200 metal presses produce all the steel body components and pressed metal parts needed for each car. More than 5,000 men and women are employed in this long-established bodybuilding plant. It is a highly mechanized plant. This iron hand swings body panels from one giant press to an ever-moving conveyor belt in a carefully planned sequence of operations. In intricate jigs, body parts and panels are fused into an immensely strong body shell. The jig opens and the body moves on to the next welding operation. After degreasing and rust-proofing, the bodies reach the paint booths, where the various coats of paint are applied. In the trim fabricating department, thousands of yards of high-quality upholstery materials are cut and sewn by skilled machinists. The bodies move steadily along conveyor lines while safety glass, upholstery, and the many fittings are placed in position. Every day, large numbers of completed bodies leave the 61-acre Woodville plant for transportation by rail, road or sea to the GMH assembly plants in the other states. Here, on one of the 5 GMH final assembly lines, bodies from the metal stamping and bodybuilding plant at Woodville, Adelaide, and engines and mechanical components from Fisherman's Bend, Melbourne, enter the last stage of manufacture. As they move steadily along the line, various components are added until the completed cars are driven off the line for final inspection and testing. So all the research, design and engineering carried out before production begins achieves tangible form. From the vision of the stylist, the skilled planning of the engineer, the detailed drawings of the draftsman, and the exhaustive road testing of prototypes, more than 100,000 Australian-made Holden cars and utilities have been produced and are now in use in the cities, in the rural areas, and in the far outback of this vast continent. Achievements such as this have made GMH, General Motors Holdens, a link in the chain of Australia's progress, a partner in Australia's future.